I'm sure you're very excited to learn about Query Engine. I am. I work at MongoDB in HR. I don't know anything about it, so this is nothing but learning for me. My name is Jen. It's nice to meet all of you. Welcome. I'm here to introduce my illustrious colleagues. One thing I'm excited about with this is I have a product person and an engineering person both on this. And isn't that like the dream team, product and engineering? I'm excited. So please, everybody, can we welcome my colleagues, Mihai, Andrei, and Xiaochen Wu. Thank you so much.
Hello, everyone. Can you guys hear me? I guess you can. OK, great. So welcome to local New York, and I hope you enjoyed the keynote earlier. And so my name is Xiaochen. I'm a staff product manager in the query and the performance team. And also today I have my colleague Mihai, the owner of this bucket hat. And Mihai, do you want to introduce yourself?
Sure. Can everyone hear me OK? All right, fantastic. So, hey everyone, my name is Mihai Andrei. I'm a senior software engineer here on the query execution team at MongoDB.
Great, thank you, Mihai. So in today's talk, we're going to talk about our latest and greatest query engine. And we're not only give you a boring talk about what it is, how it works, we're also going to review some like under the hood stories to show you how did we build this query engine. So in today's agenda, we're going to give you a quick overview of how Query Engine works. And then we're going to jump into the details about SBE, which is stands for slot-based execution engine. And Mihai is going to introduce you some details and how we build it. And we're going to show you a demo of how you can leverage this new query engine to accelerate your MongoDB queries and also your applications. Oh, by the way, guys, there's some seat in the front. Come join us and sit in the front. And then we're going to wrap up this talk with some roadmap to talk about some future improvements of our query engines. All right, before we get started, I'll give 10 seconds for the folks to sit down. And I do have a few questions for you guys so we can know you better. How many of you, please raise your hand, ever write a database query before? Any database?
Nice.
Okay, nice, most of you. Keep your hands up, keep your hands up. If you ever write a MongoDB query before, you can keep your hands up, otherwise you can put your hands down. OK, a few hands down. If you ever seen a MongoDB query plan by running an explain or some other ways, keep your hands up, otherwise put your hands down. OK, we still have plenty of people who saw like a MongoDB query plan. I guess you guys know how Query Engine works. But for the rest of the room, now the virtual room we have here, and I'm going to give you a quick overview of like how Query Engine works before we talk about like how SBE works. So Query Engine is a core part of the database, and for any database, not only MongoDB. And it passes, optimizes, and also executes the engine, and eventually returns the result to the client applications. So a typical query engine consists of 3 parts. So the first part is the query parser. The second part is the query optimizer. And the third part is the query execution engine. So the query parser is in charge of first validate this query to tell you if this query is illegal or legal. So can we run it? And then it will tell the rest of the part of the query engine what are the key components of this query, and pass down this information to the query optimizer. And then query optimizer will look for the possible query plans can answer this query, and also to choose one of the query which possibly be the fastest query plan, and send that query plan to the execution engine. And the execution engine will provide this mechanism to execute this query plan on top of the data, the documents in your collection, and then return the result to the client application. So let's look at it through a sample query here. So assume we have a collection with documents with field A, B, C, and some other fields. And so all A, B, C 3 fields are integers. And we're running a simple find query here. We're trying to find documents with A equals 1, B equals 2, and then C between 0 and 100. And in the result, we only need A and C. So we'll do a projection here. And then we want to sort the result by C, by the value of C in the descending order. So once the application sends this query to the query engine, the query parser will take it on and say, oh, this is great. This is a legal query. We can run it. And then the parser, OK, there's 3 parts of this query. The filter, the projection, the last part is the sort. And then the query parser passes this information to optimizer, and the optimizer, in this case, it's a MongoDB query optimizer, kick in and say, oh, this is a simple query, and I find a plan here. The first step I'm going to do is a collection scan with filters. The second step is going to be a projection, and the third stage is a sort. And this query plan will be passed down to the query execution engine, and the execution engine will run this query on the collection, on the data you have in your database, and then return the result to the client application. So in today's talk, we're not going to talk about details about query parser. We're not going to talk about query optimizer. We're going to focus on the query execution engine. So now I'm going to pass it to Mihai, and Mihai is going to talk about our SBE and how do we build this great query engine. Mihai.
All right, thank you very much, Xiaochen. So as you said, I'm going to talk a little bit about MongoDB's new query execution engine, SBE, and how we built it. But of course, before I talk about our new execution engine, I think it might be a little bit useful to talk about the classic query engine. And the best place to start when talking about the classic query engine is that its defining characteristic is that its execution model is document-based. That is to say, a query execution plan in the classic engine consists of a series of document-to-document transformations. That is, each component of the query execution plan is going to produce documents as output and consume documents as input. Now, intuitively, this makes quite a bit of sense, right? I mean, after all, MongoDB is a database that stores documents that are JSON-like. So it kind of follows that if we're going to store JSON-like documents, well, the query engine that's going to be consuming these documents better operate over documents. And this actually is a good thing. It gives us query plans that are relatively easy to reason about and are relatively simple, right? It's very conceptually for not only developers, but also the engineering team. It's very easy to think in terms of documents, right? However, this sort of does come at a cost. By having an execution engine where every stage has to always be concerned with documents, we have a certain level of inflexibility, right? It might be the case that a individual stage of query execution might only care about just a couple of values. As we saw in Xiaochen's query, we might only care about like 2 or 3 fields at each given stage. But we are always stuck in the classic query engine producing documents and consuming documents. So besides, I guess, this being like inflexible, this has a real penalty in terms of performance, right? If we always have to be serializing and deserializing documents, we're not going to be as performant as we possibly could be. So to give you a sense of what this looks like in practice, here is a sample query execution plan, similar to the query that Xiaochen introduced earlier. So I know a couple of you had your hands up earlier that you saw MongoDB query plans before, so this should look awfully familiar. Starting at the bottom, our data access plan is going to be a collection scan where we read each document from our collection one by one, and then we apply a filter. We're only going to pass through the documents where A equals 1, B equals 2, and C is between 100 and 0. For those documents which do pass our filter, we're then going to apply a projection. So in this case, we're just going to keep the fields A, B, and C and drop all the other fields. Finally, once the projection is applied, we're going to take all of our documents in a blocking sort, buffer them all into memory, and output them in descending order of C. So imagine that our collection has these 4 documents. Execution control is going to start at the top of our plan stage tree, go all the way down to our collection scan, and we're going to read each document one by one. And again, we're going to apply the filter. So in this particular case, the documents with underscore ID 0 and underscore ID 2 are not going to pass our filter. So they're going to get filtered out. But then the documents with underscore ID 1 and 3 are going to get passed to the next execution stage. So here, our documents are going to, they're pretty simple. We're just going to drop the underscore ID field and keep A, B, and C, as the projection specification says. And then finally, we're going to buffer all of these into memory in our blocking sort and output them with the highest values of C coming first. So for these 2 documents, that means C90 is going to come before the document with C50. So this is a relatively simple query plan, right? It only has 3 execution stages, but the big takeaway here is that this is all about documents. Even though each individual component of the query plan does something different, it has different query semantics associated with each stage, no matter what we do, we always have to produce documents, and that's what our execution state is. And this sort of brings us into sort of the motivation for our new query execution engine. So quick show of hands, who all here before coming into MongoDB local today has heard of SBE before? All right, a couple people. So I see the summer interns for query are here. I'm glad you guys raised your hands. So for those of you that are not familiar or have not heard of SBE before, as Xiaochen mentioned earlier, SBE stands for slot-based execution. And philosophically, the difference between SBE and the classic engine is whereas the classic engine is document-based, SBE is value-based. That is to say, instead of modeling our query plans as a series of document-to-document transformations, what we're going to do is we're going to break down our query plan into the values that we care about and bind them to unique identifiers called slots that we can then reference throughout the query plan. So you might ask, okay, what values might we care about during query execution? Well, first and foremost, this is still MongoDB. So one such value that we might care about are documents that we read from a collection or in any other context. Even though we want to have a more granular or a more fine-grained control over query execution, well, we still care about documents. And in the abstract, a document is just a value. But of course, the story doesn't stop there. We can bind values that are smaller than an individual document. In particular, we can bind the values associated with a particular field or even the result of some intermediate computation. But the big thing to note here is that SBE gives us the facility to break down the query into its constituent values that it cares about. So conceptually, the API of SBE is kind of similar to the classic engine. You're still going to have a tree of plan stages that is going to be responsible for executing the query. But the big difference is that whereas the classic engine, each stage is going to produce documents to feed to its parent stage, SBE, on the other hand, each stage is going to be responsible for updating the values of the slots or the values that it cares about. Another detail about SBE that's important to note here is that whereas the query semantics are somewhat opaque in the classic engine, this is not the case for SBE. To implement query semantics, you have an expression language that sort of provides the building blocks for computing values and implementing our query semantics. So, let's see. So similar to how I walked through execution in the classic engine where we saw all those documents filtering through from the bottom to the top, I'm going to walk you through the equivalent SBE plan to give you a sense of how the execution model sort of differs. So we're going to take this stage by stage, but before I describe what each individual stage in SBE does, the first thing that we need to talk about is where are the slots? So when reading a slot-based plan, and these are the plans that you might be able to see from explain output, in the same way that we get the explain output for the classic engine. The slots can be identified by the S prefix string that are followed by a number. So starting from the top, the results from our query are going to be read from S13 or slot 13. And then we have a bunch of slots also global to the plan that identify the constants in our query predicate. So we're doing A equals 1, B equals 2. The values 1, 2, 100, and 0 are bound to slots globally and referenced in the plan. Beyond the slots that we define globally, these are values of interest that are going to be global to the plan. Each individual stage in query execution is going to also define slots or values that it cares about. Starting with our scan stage at the very bottom. So just like the classic engine, SBE has to read documents from a collection. That part hasn't changed. But where the engines sort of start to differ is how documents are actually read. So when SBE reads a document into memory, the first thing that's going to do is it's going to bind the document that it reads to a slot. Here that's going to be S7, immediately to the right of scan, and also the associated record ID to S8. Another spot where these two engines diverge is, again, SBE is smart enough to execute in terms of values, right? So we have some sense when we're building the query execution plan that, well, we're going to care about the fields A, B, and C as we go throughout query execution. So what SB allows us to do is, while we're loading the document from the collection into memory, to actually do a pass over the document and look for the values of A, B, and C and bind them to slots. Now that's exactly what we see on the second line of the description of the scan stage, where we see S4, S5, and S6 are going to bind the values for the fields C, A, and B respectively. Okay? So once we've bound our initial values and done our collection scan, the next thing we need to do is implement our filter. So earlier I had mentioned that the query semantics in the classic engine are kind of opaque, but SPE doesn't really have that. To implement a filter in SPE, you have to provide a detailed description of how you want your filter to actually operate. Now, the actual individual semantics of like traverse F and lambda are not super important, but the important thing to note about the filter implementation in SPE is that whereas the classic engine has to actually take the documents from the collection scan and look up the values to actually implement to actually execute the filter, SPE doesn't have that problem because we already know what the values of A, B, and C are. They're bound to slots 4, 5, and 6. So whereas the classic engine will do the lookup A and compare it to 1, SPE will instead compare the value of S5 to S9. So where we have the values of A and 1 respectively. And the same goes for the rest of the components of our query predicate. Once we execute our filter, the next thing that we have to do is execute our projection. So we're going to take the document that we bound to S7. We're going to produce a new document where we keep only the fields A, B, and C, create a new object, and then bind that object to S13. It's eventually where our results are going to be. And finally, the last thing we need to do is execute our sort. So just like for the filter, the semantics of how we actually generate our sort by values or our sort keys are not opaque at all. You have to actually specify in detail with the expression how you want to generate your sort by values. Again, the semantics of sort keys in MongoDB are not like super important here. But what is important to note here is, again, SPE has the power to, already has the knowledge of the value of C bound to S4. We don't have to look it up again. Whereas the classic engine will have to do that for every document produced by the projection. It will again have to look up the value of C. And this sort of shows what the motivation or what's the power of SPE. You know, you can bind values that you care about and not have to look them up in the future. So just now that we've gone through the plan, here let's assume that we have a smaller collection this time, a lot more to keep track of, so we're going to have fewer documents for this part. In this case, whereas the classic engine, you know, execution again was modeled by passing documents all the way through, the state of execution in SPE is going to be the state of the slots that all of our stages have defined. Now, to start out with, our slots are not going to have any values because we haven't done anything. But once execution starts at the top of our tree and reaches all the way down to our collection scan, we're going to do what I described earlier for the collection scan and bind our document and the values that we care about to slots 4 through 8. So S7 is going to contain the entire document, but then S slots 4, 5, and 6 are going to contain the values of the fields C, A, and B respectively. Now, once the scan actually binds these values, control is going to return to our filter stage. And of course, this document doesn't match our query filter. A, for example, is not equal to 1. So crucially, execution control is not going to return above. We're not going to end up evaluating or binding a value to S13 or S14 just yet because we haven't. Our filter hasn't found a set of values that will satisfy the expression that we've defined. In other words, filter is going to keep asking its child stage to update its values until it gives it something that will satisfy the query filter. And indeed, that's what's going to happen the next time the scan stage reads another document. We're going to read the next document, which indeed does pass the query filter. Our filter is going to evaluate the expression. It's going to see that it does match. So A is 1, B is 2, and C is 50. And so control is going to be returned to our make BSON stage, where we're going to produce a new document, bind it to S13, and then we're going to also execute our sort and compute our sort key and bind that to S14. In this case, our sort key is just 50. So this is all great. We know a little bit about the classic engine, and we know about the SPE and how it works, but why bother? What's the purpose of going through all this trouble of implementing a new query engine? Isn't the old one good enough? Well, the hope with any new piece of software is you hope to see some kind of improvement in some capacity. And indeed, that's what we sort of see with SPE. SPE, the reason that we're building it is we want to see an improvement over the classic engine. As we sort of saw in the sample execution that I just went through, we hope to see improvement relative to the classic engine because the plans that we can construct in SPE will only reference the components of a document that we care about for answering a given query. So theoretically, this should give us improved query latency. Another thing that SPE will allow us to do is it will allow us to avoid unnecessary document materialization. If we don't have to create documents at every stage, that will theoretically save us some time throughout query execution. Now, beyond just improving the performance of queries that users are running today, SPE also serves as the foundation for future improvements and new features in the query language that our users might care about. Okay, so where have we actually seen performance improvements with SPE? So, show of hands, did everyone here attend the keynote this morning? Okay, some of us. So Sahir may have mentioned that there are going to be some performance improvements in the query system, and I'm not going to bore you with the numbers and go through all that again. But just to give a quick recap, the areas broadly where we expect to see improvements relative to the classic engine for SPE are queries which involve reshaping documents in some way. So these are your group by queries or your project queries, your filtering and sort queries, and also our unsharded lookups against replica sets or sharded standalone MongoDBs. Okay, this is all great. We have a new engine that performs relatively well relative to the classic engine. But how did we get to the point as a team that we have this new execution engine? Well, as I think Xiaochen alluded to earlier, this is a process that took many years, dating all the way back to the 4.4 release cycle. So this is back in 2019, 2020, where the initial prototype of SPE was implemented, and as part of a POC, a bunch of classic engine queries were taken, and the equivalent SPE queries plans were constructed, and we saw that, well, these SPE queries are outperforming the classic engine queries. And so this sort of gave us the evidence, or like the rationale to say that, okay, this is something that we should productionize. And indeed, during the 5.0 release cycle, we had our initial implementation of SPE for find. That is to say, for find queries. Now, unfortunately, during the 5.0 release cycle, so this is now fast forwarding to 2020, 2021, we did not release SPE for find because it did not have correctness parity with the classic engine. So, during the next release cycle, the 6.0 release cycle, we took a bit of time not only to close the correctness gap between the two engines, but also to expand the set of features that are supported in SPE. So, in particular, we implemented $group and $lookup in SPE. Now, even though we were able to ship $group and $lookup in 6.0, this is because they showed very clear performance improvements over the classic engine. The same could not be said for SPE for find. So even though we spent quite a bit of time improving the correctness and getting correctness parity between the two engines, we still did not have performance parity between the two engines. That is to say, the classic engine outperformed SPE for quite a number of find queries. And so during the 7.0 release cycle, so this is 2022 to this year, 2023, the next major release, we are going to be releasing SPE for find fully because during this past year, the query execution team has spent quite a bit of time improving the performance of SPE for find queries. So quite a bit of engineering effort was spent, improving all sorts of aspects of query execution for SPE. This includes, going to the implementation of each SPE execution stage and improving it in some way, or going to our expression language and improving things there, and also improving the plans that we generate. Your query execution engine is only as good as the plans you generate, so that was a big component of our effort to improve the performance of our new engine. But bigger than just the engineering effort to actually improve the engine, one of the things that we had to do during this past release cycle was to actually rethink our approach to performance. What does it actually mean for us to say that, well, one engine performs better than another engine? What queries do we even care about showing improvements in? What workloads do our customers actually care about? And so this, and also beyond that, yeah, we also needed some bird's eye view for us to be able to say, well, on the whole, SB outperforms the classic engine, so we are comfortable shipping it to you, our customers, and users of MongoDB. And so one of the neat things that came out of this past release cycle was what is now known internally as the SB performance dashboard. So besides having a bunch of like pretty colors and pretty charts, which by the way, shout out to MongoDB charts. This is what we used to produce this pretty dashboard. This gave us a lot of information during the release cycle and beyond for comparing the two engines. Most crucially, for the set of performance tests that we care about, it gave us an actual number for how many performance tests does SB outperform the classic engine, and by how much, like in terms of like percent, and also vice versa. Now, the vice versa is super important because while we were developing or improving SB for the 7.0 release, figuring out which queries the classic engine outperformed SBE and which did so most significantly was very important for guiding the team and focusing on which performance regressions or which queries we care about improving the most. Beyond just saying like raw numbers, one of the neat things about the dashboard was that also we were able to categorize our performance tests, right? It's not very useful if you just have a number that says, well, you know, some number of performance tests are better for SBE. It's more also important to know for which queries SBE is better than the classic engine or vice versa. So, you know, we had the capability to be able to say for dollar group queries, how the two engine compares, or for simple match queries, or for queries that are answered by an index scan. You know, how do the two engines compare? So using this lovely dashboard, we were able to get SB to a point where we could release it in 7.0. So that's about enough from me. I'm going to hand it back over to Xiaochen, who's going to walk you through a demo to show how SB can improve query performance for our users.
All right, thank you very much, Mihai. And you guys excited about the demo? But before the demo, I have two more things. The first thing I want to mention is that all the benefits Mihai mentioned in the previous slides, you get automatically. So after you create a 7.0 database cluster, or you upgrade your existing cluster to 7.0, the default query engine will become SB. You don't have to do anything, you don't have to turn anything on. And for certain query which SB cannot handle today, it will also automatically fall back to the classic engine. So, and the second thing is that I really want to learn about you better today. So raise your hand if you work, and I want to learn where you're from. So raise your hand if you work for an IT company. MongoDB folks, you work for an IT company, so please
yes, raise them high, folks.
All right, what about fintech? A few. What about retail? Okay, I see a few. So in today's demo, we're going to tell a story happening in a retail company. So Kyle is this engineering lead who's leading an engineering team to build a retail platform. So this retail platform consists of two main parts. So the first part is a user application. This application allows the user to browse, filter, sort, eventually to buy, to purchase their products. So imagine it's like Amazon.com or like a Walmart app on your phone. And the second part of it is an internal dashboard to allow this company to track their supply chains. So in this demo, we're going to use two different types of documents. The first type of documents are the suppliers. So it contains the supplier's name, description, address, and other information about the suppliers. The second type of documents are the products. So it contains the name, barcode, category, price, discount, and also the supplier of this product, basically who's the supplier, a current supplier of this product. And in today's demo specifically, we're going to focus on two different queries. The first query is a find query. So assume I'm going to a birthday party of my friend and I don't know what to give him as a birthday gift. So I decide to get some gift cards. So I log onto this app. I want to filter the search result by some like Google gift card, dining gift card, Hulu gift cards. I want to find someone who's cheaper, less than $50 and has more than 20% discount. And then if you are doing a lot of online shopping, you know like on the listing page, you don't see all the details. You only see the name of the product, maybe it's like a short description, the price, maybe the discount. So in this case, we just project and we only show the price, discount, and the name of the product. And then we sort this, the result by the price. For the second query, it's aggregation pipeline, and also it's for the dashboard. For this query, we're trying to find out the total price of the inventory in Washington State in each of the category. And then we're trying to find out what are the other potential suppliers across the country for this category of inventory and list that in the dashboard. So for this dashboard, for this aggregation pipeline, for the first stage is a match stage to filter the result to filter documents by the state. And then we use the group stage to group by category and calculate the total price for each of the category of the inventory. And the third stage is a lookup stage. So it's a lookup into that supplier collection and find the possible suppliers who supply the goods in the same category across the whole country, not only in Washington State. And then, because we only want to show the supplier's name on the dashboard, so we're gonna project the result and only include the supplier's name into the result. All right, so the tech support, do I just click to start it? Okay, perfect. All right. So for the first step of the demo, we created two almost identical clusters in Atlas. So they're both in AWS, I believe in Virginia, and they're both M30, 3-node replica, no backup, no sharding, and one of them is running a MongoDB 6.3, which SBE is the default engine, and another one is running 5.0, where the classic engine is the default engine. So we're going to show you the difference of running the same query, the performance on running the same query, and compare it between SBE and the classic engine. And here are the two collections we created in each of the cluster. So for the product collection, we have 10 million products in that collection. And for the supplier collection, we have 8,000 documents in each of the supplier collections. And those two collections are identical in those two clusters. And this is a query we showed you earlier. You probably cannot read it, but it's the same query. So basically, I'm going to find the gift cards, and then I'm going to filter by price less than $50, and then discount more than 20%. I'm going to sort by price. The second query is the aggregation pipeline query. So I can filter by the state of Washington, I'm going to group by category, calculate the total price, and then I'm going to find the other possible suppliers across the country and show it on the dashboard. So for the first step of the demo, we're going to show you, to keep ourselves honest, we're going to show you which version we're running. So for the SBE client, we're running 6.3, and for the classic client, we're running 5.0. In the second step, we're going to show you some information about the collections. So you see they're identical, where I have 10 million documents in the product collection, we have 8,000 in the suppliers collection. And to be able to do an apple-to-apple performance comparison, we also want to make sure the indexes we created in those collections are identical. So you see this is just like a Python code to compare the index, and they are totally the same. So for the first experiment, we're going to run that find query, the find gift card query, against the SBE engine and also against the classic engine. We're going to run that 1,000 times. I'm going to calculate the average execution time. And for the first, so we're going to clean up the query plan cache to make sure that we're doing a fair comparison here. So you can see here that when we run the query in the SBE using SBE, it uses sorry, I can't really see it from here. It's used, let me just jump down here. It uses about 8.5 milliseconds, and when you run on classic engine, it uses about like 10.2 milliseconds. So it shows about like 16.5% improvement on the SBE plan. So now I'm also showing you this query plan, SBE query plan, which is very similar to what Mihai showed you earlier, but the only difference here is that we're using S-merge, which stands for sort merge. And we're also showing you the same classic plan, and you can see here we're also using sort merge here. So I'm not going to spend time to tell you what is a sort merge. What I'm trying to tell you here is that even though we're using the exactly same mechanism to run the query, SBE will be able to process the query faster because we leverage the resource in a much efficient way compared to the classic engine. So for the second experiment, we're going to run the aggregation pipeline. Since that query is going to run a little bit slower, so we're going to run only once. And we'll also clean up the query plan cache before we run each of the query. So we're going to run against the SBE client. We're going to run against the classic client, the same query. So you can see the execution on the SBE client already finished. It took about 13 seconds. And it will take a little bit longer on the classic plan. Otherwise, I won't show you here. And so just be a little bit patient here. And I'll count down. Let's count down together.
Yay.
3. OK, great. It come out. So on the classic engine, it used about like 21 point something seconds, and it shows about like 38% improvement on the SBE engine. So in Mihai's part of the talk, we talk about, it took us almost 3-4 years for us to be able to ship this SBE engine built from scratch and made it available for our customers. So we'll learn a lot through this journey. So for the future, I think the most important thing for us is to keep improve our engineering process to be able to deliver new features to our customers in a more efficient way. So we'll keep improving our query engine to make it faster and more scalable, because we know that matters most to our users. And also, I think we also understand that the price per performance is also very important. So we hope our query engine can leverage and consume system resources in a more efficient way, so we can handle more queries in parallel in the same size of the cluster. And for the next few releases, we're also going to focus on improving the query plan generation or the optimization to make sure that we're always running an optimal plan when on different type of queries. And also in the last year, show your hand if you were at the MongoDB World last year here, the same place, Jarvis Center. Okay, a few people was here. So in the last year, in the keynote, we introduced this concept of developer data platform. So which means MongoDB is not just simply a document database, which can do insert, write, update, simple operations, but we also want to support our developers to do things like in-app analytics. Like you can introduce some social features. You can introduce some recommendation features in your application. So that requires our query engine become like a hybrid query engine. Instead of to keep supporting those document workloads in a fast way, and also we want to be able to support those in-app analytic queries in our query engines as well. The last but not the least, we will keep improve the experience for our customers to troubleshoot and also do performance tunings using our query engines. So in today's talk, we talk about our latest and greatest slot-based query execution engine, which can significantly improve the query performance and also consume the system resource in a more efficient way. So it can accelerate your workloads, your query, and your application eventually by executing a plan which is tailored to your query which is being executed. And most importantly, SBE provides the basis for our future improvements for our query engines. So in 7.0, in addition to SBE, we also introduced some other new features to our query engine and also our MongoDB servers. So include, but not limited to this list, which is compound wildcard index, approximate median and percentile support, bitwise operators, and some time series improvements. And we also start to support change stream events exceeding 60 megabytes and starting 7.0 release. So I have 2 more talks after this, talking about all these great new features. So the time series one will be right after this in the same stage. And later at 3:35, we're going to talk about what's new in MongoDB 7.0. All right, so this is our talk today. Thank you again coming here and listen to us. And we have about 5 minutes for questions. And if I have a question, raise your hand and we'll pass the mic to you. Okay, great.
Hi. My question is, what is the earliest version that SB is available?
So,
The earliest version
Okay.
where SBE is available.
Okay.
What's
So-
the earliest version where SBE is available? I don't know why I shouted. I have a microphone. There
Oh,
you
man, you beat me to it. I was about to do the trick where you like say the question to. No, I've got it. So the earliest version that SB is available is 6.0, but in 6.0 there's only support for $group and $lookup queries. The surface area of queries that are supported are expanded in the upcoming 7.0 release. That's going to include also find queries, so your match, sort, project queries.
Who else has a question?
Oh, yeah. Oh, whoops. Fun.
Does this solve the problem where you have to load a full document that's not covered by an index to read one field further up in the execution query?
That's a good question. So the question is, does this solve the problem where we have to avoid doing a fetch of the entire document where, unfortunately, no. If it is the case that you can't, there's some, whatever, if you're doing like an index scan, let's say, and you're referencing fields that are not covered in the index, you are stuck having to do a fetch anyways. But the general idea, though, is not so much about, it's not about like avoiding fetches or generating smarter query plans. It's for the query plans that we do generate, we can break them down into their constituent parts. Does that make sense? So conceptually, like a fetch is meant to, if you just don't have the document available. But versus in the example I had with the collection scan, well, if you're just loading the document anyways, you can just load the fields as needed. But you can't avoid a fetch with an index scan always, let's say.
yeah. But as I mentioned in the roadmap, that's on our radar. That's going to be something we're going to do next. So try to join us next year. You're probably going to hear about it.
It's a good question. I had to think about that one for a bit.
I was impressed by that question. Okay, one last question. Anybody? Someone does. I can feel it. There we go. Gonna make me run.
Hi, yeah, I just had a question. You mentioned there was like a 38% improvement in query execution times. I think I recall from the keynote they said a 38x improvement. Do you think that was like a bit of a game of telephone there up to the keynote?
So the question is about, in our demo, we showed a 38% improvement for a lookup query, but in the demo, the number that was thrown around was 30 times, right? 30x?
38x to be specific.
38x,
yeah.
oh man. So, good question. The performance, so the thing to remember is that the performance improvements are not uniform across the board. It's not going to be the case that every lookup is going to be 30 times faster or 38% faster or what have you. And specifically for $lookup, the improvement of performance is going to be dependent on which algorithm we choose to execute the lookup in. So I can tell you that, for example, if we used a hash join algorithm and you have a very high cardinality on the local collection, that's going to be extremely fast because you're going to have loaded your entire foreign collection. That's where you see like the 30 times improvements. Whereas I think in this demo, I forget, I don't even know what algorithm we used, but not only the algorithm that is going to be used is going to make a difference, but also the cardinality of the collections that are involved in the queries. So yes, we have actually seen though, you can do 30 times faster, not BS. So.
And also for this query for the query in the demo, we're trying to show you a more realistic, like some query you're going to use in your application and you can see in your dashboard. So it's not just a lookup. If you see the query, I have like multiple stages, have filter, I have match, have projection, have group, have lookup. So yeah, that's definitely not going to give us opportunity to show like 38 times and performance improvements. And also like Mihai mentioned, like the different cardinality of your data and the size of your data also impact like how much the performance improvement you're going to see by upgrading your server to 7.0 and be able to leverage the SBE engine.
All right, good question.
Excellent. Mihai and Xiaochen have agreed to stay for a little bit if anybody wants to come ask a question afterwards. Otherwise, can we give them a round of applause and say thank you for that?